one more thing is there. Maybe you know that maybe you're having a habit of taking tea, and to have a tea always with a very hot one, we use one kind of a device. What it is called? Thermoflask. Whether you used it? Have you seen that?
Yes, sir. I've seen it.
Yes, sir.
What do you use that thermoflask actually?
To keep the things hot or cold.
Right, to keep the things either hot or cold actually. Isn't it? Now, see here, a thermoflask generally maintains temperature of the materials kept inside it. Thus, it is used for keeping tea, coffee, milk, generally warm actually.
Yes, sir. Anything warm or hot for a longer period of time.
Right. Okay, now tell me, generally, what must be there to have a temperature constant? Suppose I poured a tea which is there at 100 degrees Celsius, and it must remain at the same temperature, and for that I used this thermoflask. And to keep this temperature constant, what must not be there?
Anything cold.
Conductors must not be there.
Very good. There must not be any transfer of what actually?
Heat.
Heat energy.
Yes, sir. Because if there is transfer of heat energy, like the heat of the tea reduces, but the heat of the surroundings increase.
Right. If transfer of heat energy is there, definitely what happens? The temperature of it will change actually. Temperature may change. But to keep temperature not to change, then definitely there must not be any transfer of heat energy. And generally, how many ways are there to have a transmission of heat energy? 3 ways are there: conduction, convection, and radiation. And here, in any of the manner, heat energy must not flow in the thermoflask, isn't it?
Yes.
So that's why the construction of the thermometer will be there like that only. And generally, a thermoflask will be a particular device which contains a double valve. What will be there? Double valve. 2 valves will be there. Now see, observe here. This is first valve and this is second valve. So 2 valves will be there, and in between 2 valves, what will be there? Vacuum will be there. Why vacuum? Why vacuum? When vacuum is there in between 2 valves,
the transfer of heat will not happen.
Transfer of heat energy may not happen, and transfer of heat energy may not happen by which process here? Either
Conduction,
by
convection.
Right, either by conduction or convection. So whatever double walled this particular structure is there for a thermoflask, this will protect from what? Transfer of heat energy from conduction and convection. So these two will not happen. And when these two are not happening, there is a chance of what? Radiation may happen. And to protect it from radiation, then what will be there is inside whatever this particular second wall is there, what will be there? Silvered surface. Silver. And why silvered surface? What the silvered surface will do? Actually, it is a poor emitter. What is a silver surface? It is a poor
emitter.
That gives out more heat energy. That means the heat energy will not be radiated much. Of the material kept inside, it is a double-walled glass vessel sealed at the top. Between the walls, so there is a hollow, almost all vacuum-like space. All those things you learnt, isn't it? There is a minimum heat loss due to conduction and radiation, conduction and convection, convection only, and radiation only. The vacuum between the walls.
No, conduction and convection. Conduction and convection.
So what will be your answer?
and convection.
Conduction and convection.
Very good. So conduction and convection. Right. So let me ask you next question. Which of the following instrument can be used to detect the heat radiation?
Anemometer.
Radiation will be there. Thermoflask will not generally measure. You have to go through the
Anemometer.
here.
Barometer.
See, thermoflask generally will keep temperature as it is, so it will not detect the heat radiation. Barometer generally will measure the pressure.
Yes, sir.
It is not a device.
Atomic pressure. Anemometer.
Anemometer is also wrong option. And what is the right option here? Differential.
Thermoscope.
And apart from differential thermoscope, other devices also will be there. Black bulb thermometer will be there, which will detect heat radiation actually. So that uses few laws of radiation, and by using it we can detect the radiation actually. So this is one thing you have to remember. Differential air thermoscope will be used to detect the heat radiation. Okay. And in solids, transmission of heat takes place generally by what?
All of the
Conduction. Conduction.
Answer is
right. In solid, most of them.
in solids, heat transfer takes place mostly by conduction, not by radiation or convection. So conduction is right answer. Okay. Next, this one you have to say. Maria inflates a balloon to its maximum capacity and places it in the freezer. After a few hours, she observed that the size of the balloon has dash because the air inside balloon has. What is the option? Observe carefully. First balloon is there.
So
She
decreased and
inflated the
contracted.
balloon and she kept it in a fridge. And in fridge generally temperature will be more or less.
So less.
Less means
So
you are
option B.
you are cooling it or not. When you are cooling it, what will happen? Generally, the balloon size will decrease. Why it will decrease? Because the air in that is
Contracted.
What is the answer here?
B. Decreased and contracted.
Okay. Next, which of the following substances is a poor insulator?
Plastic.
Very good. Iron, steel, aluminum.
Plastic.
All are metals only. See here. Whatever the options are there. Iron, one option. Steel is one option. And aluminum. All these are metals only. So all are metals except which one?
Plastic.
So metals are good conductors of heat actually. But plastic is a bad conductor of heat energy. So that's why plastic as an insulator.
Yes,
Okay.
sir.
Right.